Okay, this is day 1 of our calculus course, and we are going to discuss characteristics of functions. So whether you are in Calc Honors or IB Math Analysis SL, that was a conversation we had in a PowerPoint presentation, but I have included the information at the very end of your Chapter 1 notes and worksheet packet. So I'm scrolling all the way down to the bottom of the very last page, and we are talking about all of the different ways to represent a function. So there's a verbally, which is words, numerically, which includes data, tables, graphically would be visually, and then algebraically would be formulas and equations. And in most of the topics that we study this year, we're going to approach an idea from all 4 perspectives. So the example that we are looking at today, it's very fitting considering our current climate, is the data for the U.S. Actually, this is data for Florida on COVID deaths, specifically the CDC's number of COVID deaths, and this is a forecast model where they're anticipating where we will be beyond the week of August 15th. We're going to focus on the data that we have already. So the first question is, what is the value of f of 45? What does f of 45 mean? Well, we know that that means we are talking about when x, let me get my drawing feature up here. Here we go. We're talking about when x is 45. So when x is 45, what is y equal to? And that's what f of x means. F of x represents y. So if we look along our x-axis, I've taken the dates and I've laid underneath those dates since June 15th. That way we have an x-axis that's much easier to work with. So we're looking for where x is 45, and so that would be right here. And we're going to follow this up, and we're going to follow this over. So I think maybe, this would be 5,000 right here. So maybe that's 7,500, maybe 8,000. I'll go with 8,000. So I think f of 45 is equivalent to 8,000. My next question is, for what values is f of x equal to 5,000? So now they're telling me that y is equivalent to 5,000. So I'm looking along my y-axis, and I've already got 5,000 labeled on there from my previous example. So I'm going to follow this over in this direction, all the way over, and I'm looking for where my graph has a y value of 5,000. Once I find that point, I'm going to follow that point down, and I think that's sitting about halfway between 15 and 30, so I'm going to go with maybe 22-ish. So I think that that is occurring when x is equal to 22. Okay, I'm going to erase some of these items because this is getting a little bit messy here. All right, so what we want to do next, we go back to drawing. The next question says, state the domain. So we know that our domain is referring to our possible x values or our possible input values. So we're going to use the number line that we have underneath here, and we're going to assume that this starts at 0. And so we are going to look at the lowest y value we have and the highest y value that we have. So the lowest y value we'll assume is 0. The highest y value I'll assume is around 60. So I'm going to move the answer to part C over here. So we have x values between 0 and 60. That's one way that you can write your answer. The other way you can write your answer is using interval notation. Remember, we use brackets when you are including your endpoints. Okay, our next question is state the range. Well, we know range is referring to y values. So the lowest y value that we see is probably right around here. So if we follow that over, maybe it's around, I'm going to guess 3,000. So it looks like my lowest might be 3,000 over here. And then my highest would be up here. So we're going to follow that over. And that looks like maybe it's right around that 8,000 number that we were referring to before. So we have a range of 3,000 to 8,000. So remember, we're talking about y values. So we're going to say 3,000 is less than or equal to y, which is less than or equal to 8,000. Make sure you use y if you're referencing the range, but if you're going to use interval notation, you don't need to choose your letter. And we'll use brackets because we are including those endpoints because we have points at that lowest and highest value. All right, the next question is on what intervals is the function decreasing? Well, decreasing means as you read a graph from left to right, so as x is increasing, what is happening to y? If we are looking for where a function is decreasing, then we want to know when x increases, when is y getting smaller? So I'm going to change my color up here. So we're going to go with, let's say, we're going to go with yellow here. And we are looking for where this function is decreasing. Now it definitely looks like it's decreasing in this whole area right here. And then it increases along here, and then it's decreasing right here. So we're going to name two different intervals for letter E. So the first interval that we are going to name is from 0 to, that's looking like maybe it's around 17. So from 0 to 17, and I'm going to use interval notation here. So from 0 to 17. And then we have another interval, so oftentimes in place of the word or, we'll use a little union symbol. And then our next interval starts at 45 and heads out to 60. So from 45 out to 60. Okay. The follow-up question says, what does this mean? So we already talked about that. That means as x increases, y is decreasing. Letter F says, when is the function increasing? So we can tell that it is actually going to be increasing everywhere else on this graph. So I'll go with purple here. So it's going to be increasing in this whole interval right there. So maybe from 15 out to 45. And when is it constant? So constant would mean we're talking about something that is flat. If you had a function that did not increase and did not decrease, so as x increased, y remained the same. And we don't have any intervals like that in here, so we're gonna say none. It's never constant. All right, so let me slide down a little bit. Next question, describe what may be happening between July 1 and July 15. So July 1 is right here. July 15 is right here. That's the increasing interval. So what might have been happening in the real world in order for our number of COVID cases in Florida to be increasing? Well, that's right around the 4th of July where we hit this little bottom. And we know right around the 4th of July, everybody was getting together with their friends and their families. So that could have been one of the reasons why we started to see our cases spike. That's a subjective answer, so just make sure whatever answer you give that you justify it. All right, and the very last question, what is the difference between interpolation and extrapolation? So interpolation, you'll notice the prefix inter, and then here we have extra. So interpolation is using a graph of data to predict within the data. Extrapolation is trying to predict beyond the data. So you can see that they used this model to try and predict what would be happening next. So extrapolation would be making any predictions out here. So if I were asked to estimate how many COVID deaths I thought there would be on day 75, that would be an example of extrapolation. if I was asked to predict what I thought the number of deaths would be on day 32, that would be interpolation because it's within the data, the accurate data that we have. Extrapolation is considered much less reliable because outside the data points that we have, there could be other circumstances that are affecting your outcome. And that's just a general rule of thumb. That doesn't necessarily mean that all extrapolation is incorrect. It depends on the scenario and it depends on the model. Okay, so that takes us through our very first lesson on describing features of functions. I hope you found this helpful.